Okay, guys, so we are working in our next unit. We're done with quadrilaterals for a moment, but you'll still see them showing up. And this next set of notes that we're about to do goes on page 77, and you've got a notebook check coming up really soon. So please, please, please make sure it gets attached into your notebook on the right page. Okay, and make sure all the notes are actually there. So similar polygons are polygons with the same shape but different sizes. And what we mean by that is simply that they're going to have corresponding angles that are congruent, and they're going to have corresponding sides that are proportional. So let me go up here and let's mark this figure to match that. If these are both rectangles, well then clearly those angles that correspond, see if those two match up, are going to be equal to each other, and their sides are proportional. So let's say this side length is 1, this one's 3, well then that means that's 3 times bigger in every way. So then if I look at the shorter side and say this is 0.5, well then this will be 3 of those, so this will be 1.5. Okay, so put some numbers on your figure that would also be proportional. Okay, all right, and it's pretty simple stuff. You've done this before. I know that part is not new. But let's go ahead and go down to the next thing. We need to be able to identify corresponding parts. Now this time they give us a picture, but sometimes they just give us this statement right here. Or sometimes they give us pictures, but the pictures aren't turned the right way. Okay, so it's not always as obvious as this one is, we want to be able to match what corresponds. So notice A is the first letter there. First letter in this one is X. So just like when we did the congruent statements, I have to write them so that they correspond. So angle A is going to correspond with angle X. That means, remember, the corresponding angles are congruent. So angle A is congruent to angle X. So I'm going to write it in here, and I'm going to go ahead and mark it in my figure. Okay. We've got BC. If I look in this up here, BC corresponds with YZ. So we've got BC. Okay, now notice they're not going to be congruent. I can clearly see this one's bigger, but the corresponding lines are proportional. So notice this doesn't say congruent. It's writing the ratio. And in a minute we'll talk about how this relates to the proportions. So we would say BC corresponds to, oops, just kidding, YZ. It's easier for me to scribble it out than to actually go find the eraser. So it should be YZ there. All right, so what I want you to do is I want you to pause it, and I want you to go ahead and fill in the rest similarly, and then you can check with what I've got. Okay, so check with yours and compare with what I've got here. Make sure your angles are marked congruent and that you've got the correct segments as corresponding. Okay, pretty simple stuff. I don't think you're going to have any problems with this. The only time we do have issues is when there is no picture and we have to draw it ourselves. So just pay attention to the actual statement there. Okay. All right, let's scroll on down and look at the next example and see what we've got over there. All right, example 2 says that if the quadrilaterals below are similar, then what must be true? So I want you to notice this time it didn't write a similarity statement. They've got marked congruent the angles. And so clearly we can tell that which angles are congruent. Okay, so we can write that angle A is congruent to angle E, but that kind of seems a little silly because it's already marked for us. Okay, so I'm not going to go through and write all of these. You can tell by the pictures. What I want to focus on with this one are the sides. So notice that I should be able to tell based on what's between. See right here, AD is between the 1 and the 4. So EH is going to correspond with that. So our sides, that means AD is going to correspond with EH. So notice how I wrote them. It's in a fraction, okay? Because what we set up above is that those corresponding sides are proportional. So I'm actually going to make ratios, and I'm going to say they're all equal because that's the way that works with similar figures, is I wind up with equal ratios. And that's where you've seen this used most in the past, is we'd set up proportions and solve for missing sides. Okay. So then let's take another one, and notice I did this whole one I did the bigger one first. So this is the big figure compared to the little one. So I'm going to write it over here, big to small, just so that I make sure I put them in the right spot. Okay, so I could come over here and say, okay, well, what about AB? Well, AB is going to correspond to EF, and And I could say DC is going to correspond with HG. And all of these will give you the exact same ratio. Okay. And then our last one that we haven't written is BC. It corresponds with FG. Okay. So simple stuff. Okay. Another thing that's missing in here, since they didn't write the similarity statement, I want us to write it. Okay. And so you can get a little bit of practice with this. And so what I would do is I would take a name. Remember, when you name a quadrilateral, you've got to go in an order that I can connect. And just to shake it up a little bit, I'm actually going to start with D. So I'm going to say quadrilateral D, C, B, A is similar, and that little squiggle means similar, is similar to, and I'm going to look over here and I'm going to find what matches. Well, D matches up with the H, so I'm going to start with the H and I'm going to go in the same order. So this would become H, G, F, E. Right? Simple stuff. Simple but important. Okay. All right, now notice the way I figured these sides out is I looked at what was included between the D and the A. That went together. And so there's the term included we've used before, but it's going to become pretty important when we deal with similar figures. We've got to be able to look at, well, what's between those? Those are the two that relate. Okay, so make sure that you're able to tell what's included. And so we're going to practice that just a smidge here. Okay. So let's take a look at what we've got. In example 3 here, it says use this polygon to answer the questions. We're going to say what angle is included between AB and BC. And so we've got AB, BC. If I draw them, I can see the angle that they make is angle B. So I'm just going to say angle B. Without a picture, it's easy to tell based on what they have in common. Okay. All right, which side is included between E and D? Well, there's nothing in common when I'm dealing with the angles there. So I'm going to look at these two angles, and what they both share is they both touch this side. It's side ED. So it kind of goes backwards. When I've got two sides, I'm looking for what they both have. When I've got two angles, I include both of those. That's the side. Okay, so without looking at the picture, which angle is included between AE and AB? Tick tock, tick tock. Simple stuff. They both have an A. It's got to be angle A. And so if I look at my picture, sure enough, here's AE and AB. They both meet at A, right? And so that's just going to make our world a little bit easier if we're comfortable with saying what is included. Okay, what we did up above when we talked about the proportions, those will give us a common ratio. Right? The common ratio is what we get when, and it can also be called a scale factor. So let's go ahead and write that in here. Scale factor. When we deal with dilations in our next unit, you'll see that happen. You'll see that term used more often. But the ratio between the two corresponding sides is a scale factor. So in those rectangles we had up above, remember we had a little guy and a big guy. And where one of them had a 1, the other one had a 3, right? So that ratio, I could, depending on which order I put these in, I can either say it's 1 to 3, or I can say it's 3 to 1. And sometimes we write it like this with a colon, and sometimes we write it as a fraction, 1/3. Either way is correct. Okay. All right, so let's take a look at this example, and let's see it put into action. And we've got a quadrilateral, two quadrilaterals that are similar, and we want to find the common ratio between them. Okay, so we're just going to pick sides that correspond. So here we go. The 10 corresponds with the 5. These are simple numbers. It's not meant to make it complicated, but we will take it a little bit further in class tomorrow. So we've got 10 over 5. Okay, and notice I can use any of them as long as they correspond. So we've got 8 over 4 if I use this side. And if I go here to BC, we've got 6 over 3. And every single one of those, we always want, it should be common, which means it should be the same. That means we need to reduce them so that they're all the same. And those would all reduce to 2 to 1. So the common ratio is 2 over 1. Okay. And if you find the common ratio, it makes finding a missing side easier because then you don't have to worry about simplifying quite as much. If I want to know EF, then I'm going to say, hey, I know my ratio, common ratio is 2 to 1. And EF corresponds with DC, right, or excuse me, with AB right here. And so I know that in my bigger figure I have a 5 and I'm looking for this guy, and so we've got our proportion set up. We can cross multiply 1 times 5 divided by 2, or we can just use simple math and say, hey, it's got to be half of the 5, and we'll figure out that EF has got to be 2.5. Okay. All right. So in class on Monday, be prepared to talk about what these are and how we can use them and maybe some more complicated examples. It will get more difficult, but this is the basics. This is it. This is what similar polygons are. See you Monday.